Introduction. Dry cell is used to power our electrical device. In this above animation, when bulb is connected to the dry cell, the bulb glows. And electronic equipments. In this above animation, electronic equipment, such as toy, car, radio, remote, watch, are powered by dry cell. Because it generates electricity. Here dry cell is supplying electricity to electric device. A chemical reaction occurs in it which generates electricity. Thus in a dry cell, chemical energy is converted into electrical energy. In above animation, chemical reaction occur which is chemical energy. And this reaction result in production of electric current. So chemical energy is converted into electric energy. Electrolysis of solutions of ions. Electrolysis is breaking down of an ionic compound. Here sodium chloride, which is an ionic compound, on adding in water form aqueous solutio, and this get dissolved to form cation Na plus and anion Cl minus. By the passage of electric current. Here battery is used to supply electricity for electrolysis. Breaking down of an electrolyte during electrolysis is a chemical reaction. In above animation, sodium cation moves towards cathode and chloride anion moves towards anode. Thus chemical reaction take place by passage of electricity. Here red arrow shows that electric current is supplied by battery. Thus in electrolysis of ions, electrical energy is thus converted into chemical energy.
Definition of electrochemistry. Electrochemistry is the area of chemistry which is concerned with interconversion of chemical and electrical energy. Here in galvanic cell, chemical energy is converted into electrical energy, and in electrolytic cell, electrical energy is converted into chemical energy. Electrochemistry also deals with resistance and conductance of aqueous electrolytic solutions. In this below animation there is electrolytic solution, and there is two plate with area A. Here ion are moving. Positive ion moves towards cathode negative part of the plate, and negative ion moves towards anode positive part of the plate. So electrochemistry explain us that how much ions suffer resistance between the solution, and conductance explain how easy the ion moving. Application of electrochemical process. Electrochemical process makes possible the manufacture of essential chemicals, such as preparation of NaOH, by electrolysis of NaCl, which is widely used in the manufacture of soaps, detergents and paper. Second application of electrochemical process. Electrolysis is possibly the only means to produce fluorine. Third application is the processes such as electrorefining for purification of metals. Fourth application is electroplating for coating one metal is on the surface of another. Electrochemical cell topic. An electrochemical cell consists of two metal plates. Here in below animation, two metal plate, zinc plate and copper plate, are connected to voltmeter or carbon, graphite, rods. These electronic conductors are dipped into an electrolyte, which acts as ionic conductor, that their ions help to conduct electricity. Here and below animation zinc sulfate and copper sulfate acts as electrolyte. And in right side animation, sodium chloride acts as electrolyte. Types of electrochemical cells: electrolytic cell and galvanic or voltaic cell.
A. Electrolytic cell.
Electrolytic cell. Electrolytic cell consists of a container in which electrolyte is placed. Two electrodes are immersed in the electrolyte and connected to a source of direct current. Here electrolysis is forced to occur. Here below animation electrolysis of NaCl take place to form cation and anion by passing a direct current from an external source into the solution. Thus electrolysis in electrolytic cell is a non-spontaneous reaction. Such a electrolysis reaction which take by external source of battery is known as non-spontaneous reaction. Definition of anode. It is an electrode at which oxidation takes place. At this electrode, the species undergoing oxidation by loses electrons. Here chloride ion is species which loses electron to form chlorine atom. Here chloride ion moves towards positive electrode and loses electron thus. These oxidation reaction take place. These electrons are pulled from anode and pushed to cathode through an external circuit. Cathode. It is an electrode at which the reduction takes place. At this electrode the species Na+ ion undergoing reduction by gaining electrons to form sodium atom. Here sodium ion moves towards negative electrode and gain electron to form sodium atom.
Electrochemical reactions are made of oxidation half reaction and reduction half reactions.
Consider electrolytic cell containing sodium chloride in the form of cation Na+ and anion Cl-. Chloride ion moves towards anode and donate electron to form chlorine atom, and thus oxidation half reaction occurs at one electrode, that is at anode. Here electron are pushed towards another electrode, that is from anode to cathode. Then sodium ion moves towards cathode and accept electron from cathode to form sodium atom, and thus reduction half reaction occurs at one electrode, that is at cathode. Define electrochemical reactions. The chemical reaction occurring in electrochemical cells involves transfer of electrons from one species to the other. It is a redox reaction.
Redox reaction. Redox reaction forms the basis for the generation of electricity by chemical reactions, and also for chemical reactions brought out by means of electricity. These processes are carried out in an electrochemical cell.
Electrolysis of molten NaCl.
Electrolysis of molten sodium chloride NaCl. The electrolytic cell consists of a container in which fused sodium chloride is added. Fused sodium chloride means Sodium chloride is heated to its melting point. That is melted form of sodium chloride. During melting of sodium chloride, NaCl get break down into Na plus and Cl minus. Two graphite electrodes are immersed in it. They are connected by metallic wires to a source of direct current. That is battery. The carbon electrode connected to positive terminal of the battery is an anode. An electrode which is connected to negative terminal of the battery is cathode. Working of electrolysis of molten NaCl. Fused NaCl contains Na plus ion and Cl minus ions, which are freely mobile. When potential is applied, cathode attracts Na plus ions, and anode attracts Cl minus ions. Each Cl ion that reaches anode gives one electron to anode. It oxidizes to neutral Cl atom in the primary process. Here 2 Cl- form 2 chlorine atom by losing 2 electron to anode. The battery sucks electrons so produced at the anode end, pushes them to cathode through a wire in an external circuit. 2 Cl atoms then combine to form chlorine gas. In the secondary process, a pale green Cl2 gas is released at anode. Here both chlorine atom combine to form Cl2, that is chlorine gas. Net reaction at anode. Here 2 chlorine atom of right side of primary reaction is cancelled with 2 chlorine atom on left side of secondary reaction. So remaining left of reaction is 2 Cl- arrow and right side remaining is Cl2 and 2 electrons. Each Na plus ion that reaches cathode accepts an electron from the cathode end, reduces to metallic sodium. Sodium atom get deposited at cathode, forming a molten silvery white layer of sodium. Here 2 sodium cation accept 2 electron to form silvery gray color sodium atom. Net cell reaction. Here first half reaction is of anode, and second half reaction is of cathode. So to get net cell reaction, cancel 2 electron on both side, and so net cell reaction is 2 Na plus react with 2 Cl minus to give 2 sodium atom and chlorine gas.
Electrolysis of aqueous NaCl.
Electrolysis of aqueous sodium chloride. Electrolytic cell consists of container filled with water. Now sodium chloride is added in water to make aqueous solution of sodium chloride. In aqueous solution, sodium chloride dissolved to form sodium cation and chloride anion. 2 graphite electrode are dipped in aqueous solution of sodium chloride. 2 graphite electrode are connected by wire and battery. Graphite electrode which are connected by positive terminal of battery is anode, and graphite electrode which are connected by negative terminal of battery is cathode. The aqueous solution also contain H plus ion and OH minus ion. Working of electrolysis of aqueous sodium chloride.
An anode attracts Cl- ions. Each Cl ion that reaches anode gives 1 electron to anode. It oxidizes to neutral Cl atom in the primary process. 2 Cl atoms then combine to form chlorine gas in the secondary process.
So in net reaction at anode, 2 chloride ion convert into chlorine gas.
Cathode reaction. Here 2 water molecules form 2 H+ ion and 2 hydroxide ions. Here 2 hydrogen ion attract towards cathode and accept 2 electrons to form hydrogen atom, which in turn combine with each other to form hydrogen gas. 2 H+ undergo reduction by accepting 2 electron to form hydrogen gas. Net cell reaction at cathode. Here 2 H+ ion on right side of first reaction cancel with 2 H+ ion on left side of second reaction and net cell will be 2 H2O combine with 2 electron to form hydrogen and 2 hydroxide ions. Because Na+ ions remain unreacted and OH- ions are formed at cathode, NaCl solution is converted to NaOH solution. Thus on adding drop of phenolphthalein, the colorless solution change to pink color. Indicate sodium hydroxide alkaline solution is nature. Net cell reaction of aqueous sodium chloride.
Oxidation at anode. 2 chloride ions in aqueous state give chlorine gas and 2 electrons. Reduction at cathode. 2 water molecules in liquid state plus 2 electrons give hydrogen gas and 2 hydroxide ions in aqueous state. Here 2 electron is cancelled on both sides. Overall cell reaction. 2 chloride ions in aqueous state plus 2 water molecules in liquid state give chlorine gas, hydrogen gas, and 2 hydroxide ions in aqueous state.
B. Galvanic cell or Voltaic cell. Construction of Daniell cell.
Galvanic cell or Voltaic cell. Construction of Daniell cell. It consists of 2 containers. In one container, 1 molar zinc sulfate solution is taken. In another container, we will take 1 molar copper sulfate solution. Zinc rod is dipped in a zinc sulfate solution. And here the copper rod is dipped in copper sulfate solution. 2 rods are connected by connecting wire, and it is connected to the voltmeter, and 2 compartment, 2 container which containing solution is connected with each other by a salt bridge. So you will be wondering, what is salt bridge? So let us see what is salt bridge.
Salt bridge. In galvanic cell, the solutions are connected by a salt bridge. It is a U-shaped glass tube containing a saturated solution of an electrolyte such as potassium chloride or ammonium nitrate and 5% agar solution as shown in this figure. The ions of the electrolyte neither react with the ions of the electrode solution, neither oxidized nor reduced at the electrodes. The salt bridge is prepared by filling the glass tube with a hot saturated solution of the salt and agar solution and allowing it to cool. The cooled mixture sets to solid so that the solution does not come out on inverting the tube. functions of the salt bridge. The salt bridge serves the following functions. 1. It provides an electrical contact between the solutions and thereby completes the electrical circuit. 2. It prevents the mixing of electrode solutions. 3. It maintains electrical neutrality in both the solutions by a flow of ions.
Working of Daniell cell.
Working of Daniell cell. It consists of zinc rod dipped in a 1 molar zinc sulfate solution, and you know that in a zinc sulfate solution there are cation and anion present. In another container, copper rod is dipped in a 1 molar copper sulfate solution, and in copper sulfate solution there are cation, that is Cu+2 ion, and sulfate ion, and the voltmeter is connected the two rod. Both the container are connected by a salt bridge, and in the salt bridge we know that it is aqueous potassium chloride is present, that is K plus and Cl minus, and saturated solution of KCl solution is there in the salt bridge. Zinc rod has large number of zinc atom. This zinc atom will going to lose the electron and form Zn+2 ion, and this Zn+2 ion pass into the solution in the form of Zn+2 ion. So what is the reaction? Zinc donated 2 electron and forms Zn+2 ion. So below is the anode reaction. Zinc donating Zn+2 ion. Zinc forms Zn+2 ion and 2 electron is donated. Since here the electron is donated here, therefore this rod here, which reaction take place? Oxidation reaction take, and okay, so here the oxidation reaction has taken place, and since the electron deposited here, this will going to create a negative charge at the rod, and this rod is known as anode or negative electrode. Why it is known as anode here? Because here the oxidation reaction has taken place, that is zinc has donated the 2 electron, and you know that at anode is that place where the oxidation reaction take place. Now this chloride ion will going to move. Why this chloride ion will move here? See here, before that Zn+2 has increased, that is 2 positive charge has increased in the solution. So to balance this 2 positive charge, we require 2 negative charge so that the solution became neutral. To make it neutral, salt bridge will going to donate 2 chloride ion, that is 2 negative ion will pass into the solution in the form of Cl minus ion, and this Cl minus here. So 2 chloride ion passed into the solution and the solution became neutral. Now there is 4 positive charge and here 4 negative charge. The solution is neutral. Now this electron will going to pass through the wire, and it will go to copper rod, and the voltmeter will going to show the reading, that is, and here the deflection shown here is 1.1 volt. And this copper ion will going to move towards the copper rod, and it will going to accept the 2 electron. The copper ion will going to accept the 2 electron to form, since here the electron is lost from the rod, therefore this rod has contain a positive charge, and this positive electrode, and it is known as cathode. Why it is known as cathode? Cathode is that place where the reduction reaction take place. Here the copper ion and accepted the electron, and acceptation of electron is known as reduction reaction. So it is that place where the reduction reaction take place, therefore this rod is a cathode. So after accepting the electron, this form copper atom, and this copper atom get deposited on the cathode rod, that is copper rod. So what is the cathodic reaction? Copper ion accepted the 2 electron to form copper atom, and this is a reduction reaction because copper ion accepted the electron. Next, cell representation. What is the meaning of cell representation? How the Daniell cell different apparatus are connected to each other. So here this is the diagram. Here first thing, here you can see the zinc rod which is dipped in a, and zinc rod is a negative charge, and it is dipped in a what solution. So to show that, we have made a one vertical line here. So vertical line represent that zinc rod is dipped in a zinc sulfate solution. So this vertical line is the is dividing rod to the zinc sulfate solution. So zinc rod is dipped in a zinc sulfate solution. And what is the concentration of zinc sulfate? 1 molar. So we have to write below 1 molar. Then this solution is connected to the salt bridge. So salt bridge is denoted by a double vertical line. So double vertical line represent a salt bridge. This salt bridge is dipped in a copper sulfate solution whose concentration is 1 molar. And this copper sulfate solution is touched to what? Copper rod. So this is the copper, and copper rod is a positive charge. Now this is cell reaction. This is the first reaction is a zinc half cell reaction where the oxidation reaction take place. Here the zinc has donated a 2 electron to form Zn plus 2 ion. In second reaction, copper ion accepted the 2 electron to form copper reduction. So what is the net? So to get a net reaction, we have to cancel the 2 electron from the right hand side and the left hand side. After cancelling, what is the
Laboratory setup of Daniel cell.
Zinc sulfate solution, copper sulfate solution, zinc rod, copper rod, digital voltmeter, salt bridge and connecting wires. Take 1 molar copper sulfate solution in a clean beaker and 1 molar zinc sulfate solution in another beaker. Take a clean copper rod and dip it into the beaker containing 1 molar copper sulfate solution. Similarly, take a clean zinc rod and then dip it into another beaker containing 1 molar zinc sulfate solution. Take the salt bridge and connect the two solutions through the salt bridge. Now, take one connecting wire and using the wire, connect the copper rod with the positive terminal of the digital voltmeter. Copper electrode acts as the cathode. Similarly, take the other connecting wire and connect zinc rod with the negative terminal of the voltmeter. Using the wire, zinc electrode acts as the anode. Now switch on the voltmeter. Note down the voltmeter reading. This value gives the EMF of the cell.
Quantitative aspects of electrolysis. Quantitative aspects of electrolysis. Consider beaker containing NaCl solution, and 2 graphite electrode are dipped in solution, and it is connected to battery, ammeter to measure current, and a clock to measure time which electrolysis taken place. To calculate the quantity of electricity, Q, passed during electrolysis, the amount of current, I, passed through the cell, is measured. The time for which the current is passed is noted. The quantity of electricity passed during electrolysis is calculated using the formula Q equals I multiplied by T, where Q is charge measured in coulombs, I is current measured in amperes, and T is time measured in seconds. Example: if current is 2 ampere and time is 40 seconds, then Q equals 2 multiplied by 40. Therefore Q is equal to 80 coulombs. Therefore, charge passed during electrolysis equals 80 coulombs. Quantitative aspects of electrolysis.
How many moles of electricity passed during electrolysis if I know charge?
Calculation of moles of electrons passed. Moles of electrons actually passed equals Q divided by 96,500 coulombs per mole of electrons.
Now we substitute the value of Q as 80 coulombs. Moles of electrons actually passed equals 80 divided by 96,500. After cancelling 1 0 above and below, value form is 8 divided by 9650. By using log table, we GE value as 8.290 multiplied by 10 raised to power minus 4. Therefore, moles of electrons actually passed equals 8.290 multiplied by 10 raised to the power minus 4 moles.
Quantitative aspects of electrolysis.
Calculation of moles of product formed. Consider formation of chlorine gas, product. Here 2 chloride ion moves towards anode to form 1 mole of chlorine gas. Its reaction is 2 chloride ion give 1 moles of chlorine gas with liberation of 2 electrons. First we will calculate mole ratio. Mole ratio formula is mole ratio is equal moles of product formed in the half reaction divide by moles of electrons required in the half reaction. Here product that is chlorine gas is 1 mole. And no of electrons used in half reaction is 2. Therefore mole ratio is equal to 1 mole divided by 2 moles, which is equal to 0.5. Therefore mole ratio is 0.5. Mole of product formed is equal to moles of electron passed multiple by mole ratio, which is equal to Q divided by 96,500 multiple by mole ratio, which is equal to 80 divided by 96,500 multiple by 0.5, which is equal to 8.290 times 10 raised to minus 4 multiple by 0.5. Therefore moles of product Cl2 formed is equal to 4.145 x 10 raised to minus 4 moles.
Quantitative aspects of electrolysis.
4. Calculation of mass of product. Mass of product W equals moles of product times molar mass of product. Therefore mass of product is equal to Q divided by 96,500 multiple by mole ratio multiple by molar mass. To calculated mass of chlorine gas liberated, substituted value of Q equals 80 coulombs and then divide by 96,500 multiple by mole ratio 0.5. Molar mass is 35.5 times 2, that is 71, which is equal to 8.290 times 10 raised to minus 4 multiplied by 0.5 by 71 equals 294.295 x 10 raised to minus 4 is equal to 2.94295 times 10 raised to minus 2 gram.